the answer. So in some respects, it's possibly easier than what we have been doing. Along the same lines. But we're looking at section 4.1. We're verifying trig identities. And again, what we're looking at is how to get to a certain answer. Now, we had a discussion before school started today, before the 8:30 bell. It's not that I'm trying to prevent you from doing work in your head. You know that. You know that. However, I need you to show all your steps. I need you to show as much work as possible. It's always better to err on the side of showing too much work than not enough. I can't read your mind. Okay? Would you rather show too much work and me give you a little bit of partial credit or a whole lot of partial credit, or not show enough and then I don't know what's going on and then I have to take off more points? Do you understand what I'm saying? So it's always better, and you have to do this for this material. You cannot leave anything for me to guess. You must show all of your steps. Or all of your work. This isn't this is not coming from the conversation I had this morning. This was straight up in my notes from the last time, promise. Okay? You will understand why I need you to show all of your steps when you see what we have to do. What we're doing, folks, is kind of like a trig proof. And I know how you like proofs. And you know, in proofs in geometry, some of you are like, yes, loved them. Most of us are like, gag. We didn't like them, right? We didn't like proofs. I didn't like proofs. But it's always better to show too many steps in a proof than not enough. Now, what we're going to be doing is we'll be given an equation where you must get the left side equal to the right side. You have to balance an equation. That's what you have to do. All right? So there's no question, and you're not going to come in here and go, I didn't know what to do, so I just stopped. So I'm going to give you straight, step-by-step instructions. How and where do we start? We're going to take a few notes and then we're going to jump into it, okay? First thing I need for you to do is when you see this equation, you want to start simplifying the most complicated side of the equation. Look at the side of the equation that has the most stuff. That's the one you want to start with. It's kind of like reducing. If you had 50 over 100, it's easier to reduce 50 over 100 than it is, because some of you, if I gave you 50 over 100 and 1/2 and I said reduce them both, you would know immediately how to reduce 50 over 100, correct? Would you kind of scratch your head on if I told you had to reduce 1/2? Yeah, because it's littler. So the bigger something is the easier it is for it to whittle down into what you need. Second thing, when you add or subtract fractions, what do we have to have? We want like denominators, and what else do we want? What do we do? What did Easter say we had to do? We've got to smush them together. When you add or subtract fractions, we want to end up with one numerator over one denominator after finding common denominators. Because you have to have like denominators in order to smush them together, right? We're going to learn how to unsmush today. Speaking of unsmushing, put a star by this. If we had cosine x plus 1 over sine x, sometimes it will be beneficial to us to break that apart. Now notice that your binomial is where? Your binomial is in the numerator. When you have a binomial or a trinomial in the numerator, sometimes it will help us to bust it into how many fractions? 2. Cosine over sine plus 1 over sine. You're going to see, we're going to work an example today where you're going to see how it does benefit us to unsmush it, okay? Typically, we start over here, though, and we go that way, don't we? Isn't that what we usually do? When we're putting it together, that's what we're putting it together. We start over here with the 2 fractions and we put it as 1. Today we're going to do a problem where we're going to start with the 1 numerator over 1 denominator, and we're going to have to bust it into 2 fractions. Now, next, step 3. Folks, you got to be familiar with and use your reciprocal identities and your quotient identities. You got to know those, period. When needed. You got to use these when needed, okay? And just because some of us won't look back in our notes, what are the reciprocal identities? Cosecant is what? It's 1 over sine theta. And then what's the other one? Secant, which is 1 over cosine. Folks, you got to know those. You have to know that. You've got to use them. I mean, it's just got to be like that right there. Okay? Quotient identities. Those I think we kind of probably use those more than anything. What are those? Say it again. Bless you. I just didn't hear you. No, I don't think so. Tangent and cotangent. Tangent's what, y'all? Sine over cosine. See, we kind of use these way more. And cotangent is what? Cosine over sine. And be sure when you're doing these problems, this is a common mistake, and I bet you somebody did it on their work from last night. Folks, tangent of an angle is not sine over cosine. It's sine of that angle over cosine of that angle. You need to put the theta or the x or the y or the t. It's really important that that's there. Okay? If you didn't do it, it's fine for last night, but from now on, fix it. So you got to be familiar with those, and you got to use those identities when needed. Next thing. Everybody have that? What is it, step 4? Fourth thing. Use algebra to manipulate the equation. what did we use to manipulate the equation? A couple different things we did yesterday. What did we end up doing a lot of? What did you end up doing a lot of on that work that you turned in today? Especially those of us that we met this morning. If you were to see 1 minus sine squared theta, what did it say it again? Yeah, you should use your card, but sometimes what do you have to do to that? 1 minus sine squared theta, or it's a difference of squares. Sometimes we're going to have to factor. We end up factoring a lot, a whole bunch. We use difference of squares a lot. We sometimes, and I think maybe on one of those problems from yesterday, you had to factor out the what? You had to factor out the GCF. Sometimes you have a perfect square trinomial where you have to FOIL it out. A lot of factoring. There's also a lot of combining like terms, aren't there? How many of you on your worksheet last night come up with a problem, something like, it had something minus cosine x plus 2 cosine x, and then you just looked at it and you went, but I don't know what to do. Because we didn't think. We don't think about it. What do you end up doing with that? You end up combining like terms. You go on and add your cosines together, okay? So we have to remember all these things that we've learned in algebra to apply them to this trig stuff. Fifth thing, convert all trig functions to sine and cosine when helpful. Sometimes you just don't see it and you're like, I don't know what to do, but I'm going to change that tangent to cosine and sine, and then I'm going to go with it. I'm going to change cosecant to 1 over sine, and then I'm going to see what happens. But you're always thinking what? You're always thinking a step ahead. Always think ahead. What can I make happen? Okay? What can I make happen? Think a step ahead every time. All right, you ready? So this is how we're going to solve this stuff. What are they going to look like? You ready for this? Everybody ready? Tell me when. What's it going to look like? Stop it. I saw that, Kelly. Looking away. Y'all are going to throw yawns across the room. I can tell it already. Sine x times secant x times cotangent x equals 1. We've got to verify that. Now, does this kind of look like what we did yesterday? Let me ask it this way. Does this kind of look like what we did yesterday? Yes. But what am I given now? I've got the answer. It's going to be what? 1. Now, I got to prove that the left side is indeed equal to what? It's indeed equal to 1. We go about the process the same. What am I going to do to this? Go ahead. It's okay. Say it again. I'm sorry. I was distracted. Sine x over 1 times what? Go ahead. It's hard. 1 over who? Yeah. Find me a lemon. I love lemon. Just keep feeding the teacher, she'll be happy. Cotangent x, oh, they're divine. There we go, thank you. What if I got choked and fell over? Would y'all hit the button? Luke, would you hop over my desk? Would you leap over my desk and hit the button and say, please come save our teacher? He would leap right over that desk. Can't you see that? Hey, what now? Cancel stuff out. Very good. Why did we not go with the 1 over tangent? Because it doesn't help us accomplish anything, right? So start. Ebony's like, let's get this thing over. Come on. You're right. Cancel stuff out. We cancel the sines. We cancel the cosines. Heck yeah, what am I left with? 1. 1 equals 1. Folks, when you get that line, you know you're done. And do I have to put that 1 is equal to 1? Yes, you do. Absolutely. Is that really any different than what we did yesterday? Not really. Here's another one. Cosecant x is equal to cotangent x secant x. What do I do? What do you suggest? Hey, which side? Okay, yeah, I agree. Let's work with the right side. What do I do? Convert them. All right, so cotangent's going to become what, everybody? Cosine over sine. Times secant is going to become what? 1 over cosine. And then what? Cross out the cosines. What are we left with? 1 over sine. Now, at some point, you're going to be working a problem that is so far down your paper, and you'll see one on my smartboard. Y'all know I have to extend the page, extend the page, extend the page. Sometimes you're going to get so far down that you forget what I'm like, what am I solving for? So you look back up, okay? So look back, where am I trying to go? I'm trying to get this thing equal to cosecant x. Well, is it equal to cosecant x? It's equivalent to cosecant x, right? But I'm going to have to simplify this right here into that so that I can surely see that my left side is equal to my right side. Are you with me? That was a Bradshaw-ism. Are you with me? You remember when he'd get on the announcements? Are you with me, PC? Okay. Bradshaw-ism. How about this? What do you think? Facile, muy facile, see? Wake up. Here we go. Here's another one. Here's another one. Are we all going to do these problems the same way? Here we go. No. Don't erase it. Don't erase it. Don't erase it. Don't erase it. Hold on. Option number 1. This is for all you forest folk who go immediately to the what? Card. And you see that this is one of the identities, isn't it? This is the identity. That is equal. It's on your card, right? It's here. It's on the card. That's for you forest people. Now, you may write down card. All right? But not everybody is a forest folk. Some people are. If you're not a forest person, then you are a tree person. Look at the trees. What did you do? All right. I want everybody, I don't care how you're going to solve this on your own. For your notes, I want you to write this down. It's not going to take you but a few lines. If you are a tree person, and a whole lot of the times I am, I'm going to look at tangent squared, and I'm going to simplify that to sine squared over cosine squared plus 1. Is that what you did? Okay. That's as far as you got. Well, I have a fraction plus a whole number. What do I need to do? I can get like denominators. Okay, so that means I would have sine squared x over cosine squared x plus cosine squared x over itself, right? Because that is 1. Do you guys agree? Okay. Keep looking. Now what are we going to do? This is a very technical term. Smush them together. I want to know how you spell that. Smush them. Look at it. Smush. I think it's S-C-H-M-O-O-S-H. Smush. Oh, so it just looks fancy. Okay. Okay. What's sine squared plus cosine squared? Okay. And then what? Now it's 1 over cosine squared is secant squared, right? And secant squared. And now we've got our sides equal to each other. Here's the thing. Do I expect every person in this room to do that problem that way? No, I know that half of you are probably not going to go that way. But I want to prove to you that I'm totally okay with you doing this as long as you do what? Work it out. Show your work. I have to be able to follow your work. I can guarantee you that this quiz, whenever you have this, probably going to be next week sometime, I will give you a problem that is worked out from point A to point B. And it's going to look like the left side's equal to the right side. But somewhere in there, you're going to have to find a mistake. Or you might have, I don't know, I'll figure that out when I get there. But this would be the type of problem that I could do that. You have to be able to follow someone else's steps. You have to. Okay? So be prepared for that. Now, on a quiz or test, do I care which way you solve? No. Is there another way to solve that? Sure, probably. Are we going to take the time to do that? No, we're going to move on. Do you have any questions on that at all? Everybody cool? All right, let's look at example 4. Quattro, here we go. Secant x over cosecant x is equal to tangent x. I just saw another way to do this problem. Daggone it. Coolest thing ever. Which side looks more complicated? The left. So what should we do? Say what? Old school. Old school. Old school. I agree. Hey, see what you can do with that. Get the left side equal to tangents. You guys got this. What do I do? Talk to me. Convert it to what? 1 over cosine divided by 1 over sine, and then do what? Copy, change, flip. Multiply by the reciprocal. Then what? Cross out your ones. Yes, you could cross out your ones. I'm not going to do that. I'm going to multiply across. 1 times sine is sine x. Over shalala. I get sine over cosine, which is, I hope, because see, this is what I was telling you. I can't see. Oh, yep. How many of you had all of your steps shown Good. Hey, how many of you are going to jump from this right here to this right here? I know you're going to skip that step. I have become okay with you skipping that step. I don't like it, but I can deal with it. I can tolerate it, okay? Fair enough? So, if you're going to work sideways, use the arrows. Working down, though, is so much more easy. Here's another one. 5. I'll buy you paper. I told you I'd do that. I will totally buy you the good paper, the kind with the reinforced edge. Oh, I love that paper. It is so expensive, though. Oh, it's really good paper, though. All right. How about this one? Oh, Smarty McFarty. How do you know that? Well, because you can't really decide which side to work with, do you? For this one, I'm going to move this down a little bit. Oh, my. Guys, sometimes you have to solve both sides. Bless you. Sometimes you do have to solve both sides. Now, which side do you want to start with? You want to start with the right side. First block wanted to start with the left side. All right, so let's start with the right side. How are you going to solve it? Convert it how? 1 over cosine times, there we go. Okay. Oh, what now? Oh, okay. All right. Well, we cut. Do you see what happened though? We get there and we're like, oh, what do we do now? You just go to the other side and you start solving it. That's why first block must have did this one first. So how are you going to rewrite the left side? Listen to you. Sine over cosine plus cosine over sine. What now? Now we got to find a common denominator, which is going to be what, Cindy? Cosine sine. Uh-oh, I'm seeing a pattern here. Look. Look at the right side now. And then look at your left side. What we have on the left side. Hey, we got the same denominators. That's a good thing, right? All right. What is we multiplied sine, so sine times sine is sine squared. Y'all with me? We multiplied cosine to the second denominator, multiply it to the top. Cosine times cosine is cosine squared. And our very highly technical term, smush them together. Write it as 1 numerator over 1 denominator. Isn't what? The numerator is 1 why? Because the card. That's the Pythagorean identity, which is 1. Uh-oh. Do you see something happening here? Heck yes. Now we got the same thing. Now go ahead and bring down. What is cosine times sine? Cosine sine. Do I have the left side equal to the right side? Yes. And is it okay that my right side does not look like my original right side? Yeah, it's fine. As long as I have my left equal to my right, I'm good to go. What do you think? It is easy. Okay? That's good. Because tomorrow I'm going to blow you up. I can't wait. Can't wait. Here's another one. Tangent t minus cotangent x. X Bless you. Did you see anything like that yesterday? Yeah, that kind of looks familiar, doesn't it? We love those problems. Yeah, I would go old school on which side? On the left side. Folks, I'm going to give you a few minutes and see what you do with this. You don't need me guiding you through every step. See what you can do. You've already done this problem for homework. You did it last night. It's back there on my desk. Ha 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 ha. Do it again. Everybody decided to work with the left side? Bless you. Yeah, left side. All right, I'm going to old school. Here's something that will be beneficial to you. Pardon me? I would have written to write negative cosine squared minus plus sine squared. Is that what you're saying? Yeah. 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 Yeah, you can work either side. Whatever one you want to work. Just as long as you show your steps. That's fine. What would you have done to the right side? Does anybody see what you could have done to the right side? It's difference of squares. Sine minus cosine times sine plus cosine. Those are the types of things you got to train your brain to see. Anytime you have a squared minus another squared term, it's difference of squares, okay? And use it. Use it. Here we go with the left. Did you guys go sine x over cosine x minus cosine x over sine x? Yeah? And then same thing with a plus. And then dang it, what do we have to do? We have to get common denominators. Ugh, right? We know it's going to be cosine sine. Y'all remember doing this problem yesterday? I remember looking at it this morning. Same thing. Whole lot of work. What's going to be your new first numerator? Sine squared. What's your new second numerator? Cosine squared. New third numerator? Sine squared and then cosine squared, right? All right, so then we smush them together and we're going to copy, change, flip all in the same line. Do you guys agree with that? Are you okay with that? Good, awesome. Thank you for your feedback. Okay, now what? The cosine sine, they cancel out. Okay, boom, boom, done. What else?
50 cents then be common for the bond.
All right, this thing right here equals 1. So I'm going to rewrite this sine squared x minus cosine squared x over 1. What am I trying to get to? Because, see, you guys can see it on your paper. Oh, look there. That's what I needed to get to, isn't it? Cindy just watched the video. Okay? I'll look at my homework page, and the assignment will be on there. Is that okay? How many of you had that? You got your right side equal to your left side or vice versa? Questions at all? Great. You guys need to stop with all these questions. I hope so. I hope that's what that means. Here we go. I hope that's what that means. Here's one. Cosine x. Again, with the different ways to solve. Cosine x times the quantity, secant x minus cosine x is equal to sine squared x. What are you guys seeing? What are your thoughts on this? We got multiplication and division, or multiplication and addition, yes? What else? Maria, what are you seeing? Use the distributive property. Do you guys see that? Are you lying? You're okay. Does anybody see anything else? One minus cosine squared x. Okay. So are you going to start working with the right? You're just saying. Okay, you're right. That could happen. Is that going to be beneficial to us? Not right now. Not right now, but it might in just a few minutes. Keep that thought. In a few minutes, it might. What are we going to do? Distribute. You want to do that? We can do that. All right, go ahead with your bad self. I'm going to distribute. Seriously. No, I didn't mean that. I mean, go ahead. Do the problem your way. Let's see if we get to the same. Hey, remember what Jansen said? Remember he said sine squared x is going to turn into 1 minus cosine squared x, didn't he? Okay, does anybody see anything? Are you looking ahead on this? What am I going to do with cosine and secant? Oh, okay. What now? Cross out the cosines. And then what are we left with? 1 minus cosine squared x. Hey, what's sine squared x? Jansen, what's sine squared x? Oh. What did you multiply by cosine x over 1? You have to distribute. Why do that? Tell me why I have to distribute. No. Why? Why do I have to distribute, y'all? Seriously. What's the clue? Parentheses. You're multiplying cosine to that quantity, so you have to distribute. Yeah? That'll work. There is more than one way to skin a cat. That's not the moral of the story, though. The object of this game is to get the left side equal to the right side. I don't care how you do it, as long as you don't cheat to do it. Okay? It's fine for you to do that. It's fine for us all to do these problems differently. That's why I love this. Because I can't force, I just can't do that. I can't do it. Last one. Check this out. This one, a couple of different things we could do with this. 1 plus cosine y over cosine y is equal to tangent squared y over secant y minus 1. Ugh, what the world? Options. You want to go straight to the card right off, right? Okay. Let's write our options down. We're not going to solve them every different way. You go straight to the card. Because you locked into that squared term and you're like, I know it's on my card. That's good. What's another thing we might be able to do? Who wants to solve the left side first? Nobody. Who wants to solve the right side first? 2 of you. The rest of you, what are the rest of y'all going to do? No, it doesn't really matter, but I just want you to see the different ways what we can do. Solve left side first. Write this down. Solve the right side first. Come on, somebody's got to see this. There's one more way. What? Who said that? Attaboy. Isn't this a fraction equal to a fraction? Guys, let me show you something. Yay! I love proportions. If you have a fraction equal to a fraction, and it's totally doable because I did it last class. Well, I'm like the Dos Equis guy. Yeah, you know that commercial? That is the funniest commercial on TV, and I don't need to record this. Isn't that how you say it? Here we go. What was on your card, Tyler? Tangent squared y. What was on your card? Ah. All right, I'm going to write this down. I'm going to keep writing down my left side. You said tangent squared y straight from the card was what? Secant squared y minus 1 over secant y minus 1. That's straight from the card, and you might want to put that card. Anybody seeing anything else that you can do? Now I cannot cancel this cosine right here with this cosine because the one at the top hold hands. This is a binomial, that's a monomial. You can't cancel. Say it again. How? Why? No, can't do it that way. I can, you're on the right path, but not that way. I could. Oh, I could. No, it isn't. Do it that way, Zach. You're looking at the left side and you're going 1 over cosine plus cosine over cosine, aren't you? Do it that way. Tyler, what are you seeing? No, you want to do the same thing. Guys, look at that first, the right numerator. It's a difference of squares, which means it's going to cancel. It won't cancel. It will break down into what? Secant y plus 1, secant y minus 1. All right, how did we get there? Difference of squares. Now what's going to happen? This is what you were wanting to do. Now I can cancel my, secant y's minus 1. And I'm left with, did that help? It did? That doesn't equal 1 plus cosine y over cosine y. Say it again. Well, I'm not done with the left side. What do I have to do to it? He's already told us what we have to do to it. We have to unsmush it. It's smushed together, right? So we're going to unsmush it by writing 1 over cosine y plus cosine y over cosine y. Look what's getting ready to happen. What's 1 over cosine y, everybody? Secant y. Plus who? Hallelujah. Isn't that cool? I love these problems. I know I say it every day. Every class, every day. But I really do love these problems. That's kind of cool. It is really cool. All the cool kids know how to do this. And y'all are all cool. Question. Proportion. I got to cross multiplied. If you wouldn't have recognized the difference of squares, you could have turned it into 1 over cosines. You could have gone old school on the left side. Could have gone old school on both sides. I mean, it's infinite possibilities. Okay? Yes, ma'am. Hold on. Other questions? None? Fun times. You know what's getting ready to happen, don't you? Fun times. Right, you ready? Whatever, right? Here we go. Page 243. 23 through 25, 27 through 29, 32 and 33. Folks, on number 32, be mindful that that problem has like sign of negative x. What are you going to do with that negatives? Just move it to the front. That's just like what you saw yesterday. Just take that negative sign and move it to the front. When you see it, you'll know what to do, okay? Working on this now.